Oh, reminder when you're dealing with the radicals. Typically, what's going to happen, I'm not going to put all the left and right and up and down because I did that when we did the initial notes, and it's okay to look back at that stuff. So what I'm basically going to tell you here is almost all the time, except for our oddball problem, number 4 we're going to do, this value is going to affect your x value. And typically, these two, I'm going to label them, you're going to think I'm doing slope. I'm not doing slope. Are going to affect your y value. If you have both ever, the a value will be a multiply number that you will do first to your y value, hence the y1. And the k value will be an up or a down, an add or a subtract number to your y value. That always comes second if you have both. If we don't have an a value to deal with, we just do the plus or minus for y, and we're done. That's why I like to play with number 2, because we get to see everything. So on this one, we're still going to be basing off of our parent graph. Knowing those 4 values is going to make your life simpler and make you faster at this. And we've seen before with the length of tests and quizzes, you've got to have some semblance of speed with this stuff if you don't want to be in a rush. So, what am I going to do here? Well, let's see. So I look inside and I see this plus 1, which means we're going to go left 1, or we're going to subtract 1 from each of our x values. So it's the opposite of what you see. So I'm going to take my x's. I'm just going to go ahead and do this. Take 1 away from each of those. That's why I like having that chart there. Now, y, there's a couple things going on. And I'm actually going to write my directions here as I go. All right, so left 1. Then I see I've got a vertical stretch of 3. That's my first job with y. And I'm going to go down 5. That's my second job. Mathematically, what that means is my first job with y is going to be, I'm going to multiply by 3. And then my second job is I'm going to subtract 5. And I have to do them in that order, or this is going to get messed up. So negative 1 times 3 would be negative 3, minus 5 would be negative 8. 0 times 3 is 0, minus 5 is negative 5. 3 times 3 is 9, minus 5 is 4. Holy moly, 8 times 3 is 24, minus 5 is 19. That's going to be a little bit off the page, so that's not going to help us quite as much. So I start to look at this, and I always just make sure that I don't do something silly on my... Yep. Okay. Wanted to make sure we didn't do anything crazy. So here's my new points. I'm even going to pop this up on the calculator in a minute just so we can see. Hardy, can I do this on the calculator? You can. But again, sometimes that may slow you down with some things. So I'm like, all right, so 3 square root x plus 1. Right now, if I kept typing, I'm still under the radical. That minus 5 isn't under the radical. So if I'm going to do the calculator, I got to do that part. So if I pull my chart, okay, there's the error messages starting, and this is why I checked this, because I did something screwy. What did I do screwy? Somebody's like, Hardy, will tell you did something screwy. All right. Why is it losing the 3? Let me guess. Oh, people, nobody even told me till now. I just figured out what I did. What goofy thing did I do? Yeah, I think what I did too, because I did multiple things, I think I went back to my x values. Oh, I did. I went back to my x values. That's no good. Great lesson right off the bat from Hardy. I need to cover that up so I can't see them. 0 times 3, that's -5. I was wondering why those numbers were so big. 1 times 3 is 3, -5 is -2. Okay, I'm feeling much better now. 2 times 3 is 6, -5 is 1, and 3 times 3 is 9, -5 is 4. That's so much better. So much better. Lesson learned from watching the teacher do a goofy thing. All right, so now that I have legitimate numbers and I can see that, sometimes checking on the calculator, not a terrible idea. Okay, I got all my numbers right now. -1, -5, 0, -2, 3, -3, +1, 8, 4. So once I've got that, reminder on domain and range, because you've been given a wonderful hint, but I'll show you graphically first. My domain goes left to right, x value, so it'd start at -1 and go to infinity. And my range starts at a bottom here of -5 and goes up forever to infinity. But here's the thing. If you went chart mode, you had them given to you already. Okay, so it's a nice visual for dealing with domain and range that you get as a bonus. So probably the best way to go more times than not. Either in your head, I don't care, or showing in a chart, not a bad idea. The only time this little pattern of ours changes is if we end up with a coefficient in front of our x value. Then I have a different suggestion. So here I look at this and I'm like, what the heck? We have to make sure that this value, this 4x plus 20, is greater than or equal to 0. Because otherwise we get error messages. We don't want error messages. So, as we saw last week, if I take that and I set that equal to 0, and I solve the little mini equation, that's telling you where your first value of x is going to be. Hardy, what about the 0, 1, 4? When this is inside, I don't have to play that game because I'm going to let the calculator do most of this for me because this gets a little more complicated. So I sit there and I go, okay, well, -5. So what happens if I plug in -5? 4 times -5 is -20, plus 20 is 0, -3. So all I did was I plugged in the -5 and I got a y out. There's not an easy way to get the other values. It's not just going off of these now anymore. So this is the one time that I'm going to tell you it's going to be easier if you type it into the calculator if this value isn't just x. Because now, if you pull the chart, okay, there's the -5, -3 that I just got. And I'm literally going to go in here and I'm just going to pluck whatever whole number values I can. But I do want to give you a little bit of an explanation of where they're coming from. So sometime, let's say you don't have a calculator available or something that you're not, I can't do any of these. The whole reason we always use 0, 1, 4, and 9 is they're perfect squares. They're going to break down nice. -5 broke down nice. It gave me 0. So next, -4, 4 times -4 would be -16 plus 20 is 4, a perfect square. It breaks it down. -1, 4 times -1 is -4 plus 20 is 16, a perfect square. So if you had to, you would just kind of throw some numbers in for x until you found perfect squares that would break down nice. 4 times 4 is 16 plus 20 is 36. 36 is a perfect square. So this is the one time we like going to the calc, when that's going on. Hardy, does it mean I can't go to the calculator times? No. But I will say this, if you mess up a graph and you're just using the calculator, number one, you're not going to know it. And number two, I'm not going to have places I can give you partial credit on a quiz or a test in this case. So I get that in there. So does that change our domain and range rules at all? No, not a bit. I am going to write my transformations in here in a minute, and then I'm going to be done and get out of the way. So I look, starting at -5, going to infinity, first x value. Y, starting at -3, going to infinity. That doesn't change. Okay, that first point's still going to give you the value that you're looking for there. So again, play with these some. Check answers as you go. Make sure that you're on top of this and not constantly